Alright, in this video I'm going to talk about odd and even functions. So an even function is described as a function that if you were to change your inputs to the opposite inputs. So for instance, if I were to plug a 5 in here, and then if I switch that to a -5, the function still gives me the same value either way. So if I switch the x values to the negative versions of the x values, the two functions should remain the same. So an example of an even function would be a quadratic function, a parabola that's going up vertically. You'll notice that even functions will always be symmetric about the y-axis, meaning that if I were to divide this in half and fold it over itself, it should lay right on top of the other side. So once again, even functions are anytime we take our inputs and we switch them to be negative values, we should get the same function values out, which means it'll be symmetric about the y-axis. Now, odd functions, on the other hand, will be if we change the x values to a -x, we'll actually get the opposite y values out. So if we switch the x's to the opposites, we'll also get the odd y's. And this is called an odd function. An example of an odd function would be a cubic function that I have graphed here, and it is symmetric about the origin, or in other terms, it's just a 180-degree rotation. Notice that if I were to take this part that I'm kind of tracing, if I were to take that part and rotate it 180 degrees, it would lay over top of this other part, and it would have a symmetry based on a 180-degree rotation. Now, what we want to be able to do is identify even and odd functions, and there's really kind of two steps to being able to do this. We need to replace the x with a -x, and then simplify and see whether or not it's still equivalent. If it's still equivalent, we know it's even. If we get the opposite of the original function, we know it's odd. So hopefully this makes more sense when we go through example 1 here. So if I look at example 1, I have f of x equals x to the third minus 7x, and I want to switch the x to the -x. So for every x that was in my original function, I now have to put in a -x. Notice that I have to put in parentheses when I do this. So I'm switching all the x's with just -x's. Now I have to simplify. So if I look at this function f of -x, well, if I take -x to the third power, well, a -x times a -x times a -x is going to be a -x to the third. And then -7 times a -x is going to give me a positive 7x. Now, if you notice, if I look back up at the original function, I don't get the same function back when I plug in the -x. Instead, I have a -x to the third rather than a positive x to the third, and I have a positive 7x instead of a -7x. So this is not going to be an even function, because remember, an even function should be that when I switch the x to a -x, I get the same function back. As we can see, that did not occur, so this can't be even, and therefore this is going to be an odd function. Now, one last thing to kind of note, and this is kind of tricky to see, I could take this a step further to make it more obvious that it's an odd function. If I were to divide by a -1 and factor it out, I would get -1 x to the third minus 7x. And now you'll notice that the definition of an odd function, if I plug in a -x, I get a negative whatever the f of x function was. And you'll notice I now have the f of x function, but I have the negative in front. So this is indeed an odd function. Alright, let's go ahead and look at a second example here. So suppose I have x squared, or example 2, suppose I have x to the fourth plus x squared minus 1. Once again, I'm starting off by switching every x value with negative x. So I have to take parentheses negative x to the fourth plus negative x squared minus 1. And then I just simplify this. Well, if I take negative x to the fourth, that's really negative x times negative x times negative x times negative x. And if I multiply negative x 4 times by itself, well, I'm going to get a positive x to the fourth. And then if I take negative x squared, well, that's just negative x times negative x. Well, that'll give me a positive x squared. And then I haven't done anything to the negative 1, so that just stays the same. Well, if I look at my two functions, notice that g of x equals x to the fourth plus x squared minus 1. And I see that g of negative x equals x to the fourth plus x squared minus 1. Notice that these two functions are the same. Because they have remained the same, we would say that this is an even function. Now, some individuals might look at these two examples and think, well, this one's got all odd powers, right? It's got a power of 3 and a power of 1. So obviously that's going to be odd. And then they're going to look at this one and say, well, yeah, these powers are even, so obviously it's an even function. The definition of even and odd functions do not work like that, so make sure you do not make that simple mistake. If it were that simple, we wouldn't have to go through these steps in the first place. We would just say that that is the case. So that is not the case. Make sure you do not do that. Remember, anytime we identify even and odd functions, we replace x with negative x, and then we simplify. If we get the same function back after we simplify, it's an even function. If we plug in negative x and simplify and we don't get the same equation back, then it's an odd function.